guys, we're working on fractions again. I know that excites you. On today's worksheets, we're still going to be working with fractions and simplifying fractions, but these word problems are going to be a little bit harder. We're going to have to read them very carefully to find out exactly what it's asking us for. Since we know we are going to be simplifying our final fractions, we know that we're going to be doing part of a whole. So we'll go ahead and put that up there. On number 1, Stephen collected 36 box top coupons in total. He gave 18 of them to his sister. What fraction of box top coupons did Stephen finally hand over to his teacher? Okay, so we're going to have to really read careful on this one, aren't we? These are those kind they give you on those standardized tests that try to throw you off, but we're going to be smarter than they are. All right, it says, we know we're dealing with a fraction, and we said it's always easier to find the whole first. So Stephen collected, okay, it says he collected 36 box top coupons in total. So our whole number of box top coupons is 36. And then the other number it gave us, it says he gave 18 to his sister, but that's not what our question asked, is it? It says how many did he finally hand over to his teacher? So I'm gonna have to do a little bit of something before I figure that out, aren't I? Okay, he had 36 to start with, and he gave 18 to his sister. So if he gave them away, we know we're gonna subtract, aren't we? Okay. So 36, and we're going to take away the 18 that he gave his sister so we can see how many he had left to give his teacher. Okay, so can't take 8 from 6, so we're going to have to borrow here, and that's going to become a 16. So 16 minus 8 is 8, and 2 minus 1 is 18. So how many did he have left to give his teacher? He had 18 of them left. Okay, and then we need to see if there's anything that we can use to simplify that. Is there anything that'll go into 18 and 36? Let's see what happens if we divide them both by 2. Okay, 18 divided by 2, we know that one from mental math. That's 9. And then 36 divided by 2, that's a little bigger, so let's go ahead and work that one out. 36 divided by 2, 2 goes into 3 one time. 1 times 2 is 2, and then we subtract. 3 minus 2 is 1, and then we have to bring down that 6. 2 goes into 16. Okay, it goes 8 times. 8 times 2 is 16, and we subtract, and yeah, we get 0 remainder. So now we know that 36 divided by 2 is 18. So we've simplified it a little bit more. All right, let's see. Is there anything that will go into 9 and 18 evenly? Okay, 3 won't, and 4 won't. Hey, 9. Let's try 9. 9 divided by 9 is 1, and we already know by doing mental math over here that 18 divided by 2 is 9, so 18 divided by 9 is 2. And we know that's in simplest form because we have a 1 in it. Bailey, quit ringing your bell. I'll take you out a little bit. Okay, so half of the box top coupons were given to his teacher. All right, number 2. A cardiologist had 19 appointments, and a cardiologist, that's just a heart doctor. We know we're doing a fraction, so we're still doing part of a whole. Okay, the cardiologist had 19 appointments fixed for Tuesday. 5 appointments were canceled that morning. What fraction of patients kept their appointments with the doctor on Tuesday? So let's see, the whole number of appointments that he had for Tuesday was 19. And then my question asked me, what fraction of patients kept their appointment? Well, it didn't really tell me how many kept their appointment, but it did tell me that 5 canceled their appointment. So if he started out with 19 appointments, if we take away 5 of those appointments, then we'll know how many people kept their appointment. So 9 minus 5 is 4. 1 minus 0 is 1. So 14 patients still kept their appointments. And then we have to look, is there anything that I can divide 14 and 19 by and get a 0 remainder? Okay, I know 2 doesn't go into both of them evenly, or 3, or 4. I can't think of anything. Okay, so if there's nothing else that I can divide both of them by and get a 0 remainder, then I know it's in simplest form. So 14 19ths, or 14 out of the 19 patients kept their appointment. All right, number 3. We're still finding what fraction, so we're still finding part of the whole. Number 3 says, Paula baked 2 batches of chocolate chip cookies. She used 3 cups of flour for the first batch of cookies and 2 cups for the second batch. What fraction of flour was used to make the first batch of cookies? Now, let's see. In this one, let's see. How many whole batches did she make? She baked 2 batches of chocolate chip, and let's see. It doesn't tell me, does it? But let's see. If she used 3 cups for the first batch and 2 cups for the second batch, all right, that means she used 5 cups altogether, didn't she? She used 5 cups of flour altogether. So even though it didn't give me the number, always read your problem very carefully. So even though it didn't tell me how much flour she used as the whole for all of it, I can figure it out because she used 3 for the first batch and 2 for the second. So now it says, my question says, what fraction of flour was used to make the first batch? And if I read my problem again, it says she used 3 cups of flour for the first batch. So the part that she used for the first batch was 3. And then I have to see, is there any number that I can divide 3 and 5 by and get a 0 remainder? Okay, we know 1 wouldn't do any good, and 2 doesn't work, and 3 doesn't work. So there's nothing that I can divide into 3 and 5 and get a 0 remainder. So 3/5 of the flour was used on the first batch. Okay, I'll leave those words up there. We're still going to be finding our fraction. We're still finding part of the whole. All right, on number 4, Mr. Hobbs has 11 blue markers, 5 black markers, and 7 red markers on his desk. What fraction of black markers can be found on Mr. Hobbs' desk? We said it's easier to find the whole first, but it doesn't tell me how many whole markers he had, did it? Oh, but it did tell me how much of each color he had. So I know if he had 11 blue ones, and he had 5 black ones, and he had 7 red ones. I can add all those up and see how many he had all together, can't I? Okay, so 1 plus 5 is 6. 6 plus 7 is 13. So I carry my 1. 1 plus 1 is 2. So all together he had 23 3 markers. So even though it didn't give us the number, we could tell by reading the problem how to get that number. We could find out how many whole ones he had. And then the question asked how many black ones could be found. Well, when we wrote this down, that tells us right there, doesn't it? It was 5 black ones. So 5, the part that was black ones, was 5 out of 23. So 5/23 were black. And then we have to see, is there any number that I can divide 5 and 23 by and get 0 remainder? All right, we know 2 won't work because they're not even, and 3 doesn't, and 4 doesn't, and 5 doesn't. So I've made my way all the way up to 5, and there's nothing else. So I know that 5/23 is the simplified answer. 5/23 of the markers were black. All right, on number 5. There's a total of 52 building blocks in a bag. Sean uses 38 blocks to build a house. What fraction of the building blocks remain unused? Well, we can find the whole. He had 52 in all. That's what he had to start building with in the bag. And it asked me how many are unused. Well, it doesn't tell me that, does it? Okay, let's look at that. All right, he used 38 to build his house, though. So if he had 52 to start with, and we take away the 38 that he used for his house, then we'll know how many he didn't use, won't we? Okay, we can't take 8 from 12, so we'll have to borrow. And that becomes a 12. Excuse me, you can't take 8 from 2. So we had to borrow, and it becomes a 12. All right, 12 minus 8 is 4. 4 minus 3 is 1. So if we take away the 38 that he used to build his house, now we know that 14 were unused. So now we have our fraction. And we always need to make sure it's in simplest form. Okay, is there any number that'll go into 14 and 52? Well, since 2 will go into 4 and 2, I will try 2. Remember, sometimes we just have to do trial and error. Okay, 14 divided by 2. Now, just for mental math on my math facts, I know that is 7, right? But 52 divided by 2, I'm not really sure about that one, so I'm going to go to the side and work that one out. 52 divided by 2. 2 goes into 5 2 times. 2 times 2 is 4. And we subtract. 5 minus 4 is 1. And we have to bring our 2 down. 2 goes into 12 6 times. 6 times 2 is 12. And if I subtract, I get a 0 remainder. So now I know that 26 is simplified. Now, is there any number that I can divide 7 and 26 by and get a 0 remainder? I know 2 doesn't work because it won't go into 7, and neither does 3 or 4 or 5 or 6. 7 does, but that wouldn't do me any good, would it? Okay, so now I know that if there's nothing else I can divide 7 by, I have to do it to both of them. So I know that 7/26 is my simplest form. So he had 7/26 of the building blocks that remained unused. So just because it doesn't give us all the numbers, we got to read that problem and see if it gave us enough information to find that number, and it did. So let's move on to worksheet number 2. We are still working with taking our word problems and finding our fractions. So we're going to leave part and whole up there. Okay, and number 1 on sheet number 2 says Mrs. Graham placed 6 red, 8 yellow, and 7 white roses in a vase. What fraction of the roses are yellow? Well, let's see. I need to know how many whole roses I had all together, and Well, it doesn't tell me that anywhere, but I do know that 6 were red, and I do know that 8 were yellow, and I do know that 7 were white. So I know how many of each color she had, and if I add them up, that'll tell me how many she had in all. Tell me how many whole roses she had. So 6 plus 8 is 14. And if it helps, go to the side. 14 plus 7. 4 plus 7 is 11. And we carry our 1. 1 plus 1 is 2. So all together, Mrs. Graham had 21 roses. So there's how many whole roses we have. And then the question asks, what fraction of the roses are yellow? Well, since I wrote my information right here, I know how many were yellow. The part that were yellow is 8. Okay, so then, is there any number I can divide 8 and 21 by and get 0 remainder? 2 won't go into 21 evenly. 3 doesn't work. 4 doesn't work. 5, 6, 7, 8. I've made it all the way up to 8, and that's the highest I could try. So 8 of the 21 roses are yellow. All right, number 2. A local community bank has 31 employees on its rolls. 15 employees work part-time at the bank. What fraction of full-time employees work in the bank? Well, if I'm doing a fraction, I know I'm looking for part of a whole, and we said it's easiest to start by trying to find the whole. How many whole employees work at the bank? Well, my first sentence tells me 31 employees. So the whole number of employees that work there is 31. And my question asks me, what fraction of full-time employees work at the bank? Well, the only other number it gave me was 15, and that was about part-time workers. But if I know I had 31 to start with, and I take away the 15 that only work part-time, then I can find how many are there full-time. All right, so I can't take 5 from 1, so I have to borrow, and the 1 becomes an 11. 11 minus 5 is 6. 2 minus 1 is 16. So if I have 31 employees, and I take away the 15 that work part-time, now I know what part work full-time. So now I have my fraction to start working with, and I have to see, is there any number that I can divide both of them by and get a 0 remainder? Well, they're not both even, so I can't use 2, can't use 3, 4, 5. I could just keep going on this one. I don't see anything that I could divide both of them by and get a 0 remainder. So 16 of the 31 employees, that's the fraction, the part of the whole, 16 31sts are the number of employees that work full-time. All right, number 3. David was gifted a 28-piece puzzle by his aunt. He has fixed 19 pieces of the puzzle. What fraction of pieces does David need to fix to complete the puzzle? Okay, so first, we said it's easier to always start with the whole. So let's, how many whole pieces of puzzle did he have to start with? Let's see, he had 28 pieces to his puzzle. And the question asked me, how many does he still need to fix? Well, it didn't give me that number in the problem, but it did tell me how many he already had fixed. So I know if he had 28 to start with, and if I take away the 19 that he's already fixed, then I'll know how many he still has to complete. I can't take 9 from 8, so I have to borrow. and that will become an 18. 18 minus 9 is 9. 1 minus 1 is 0. So now I know when I take away the 19 that he has already fixed, he only has 9 that he still has to complete. And then I see, okay, so I know that 9 28ths, he still has to complete 9 out of the 28. Is there any number, let's see, I can't divide it by 2 and get a 0 remainder, or 3, 4, 5. No, there's no other number. So the number or the fraction that he still has to complete is 9 28ths. Okay, number 4. We're still looking for fractions, so we're still doing part of a whole. Okay. 20 girls were dressed in green outfits, and 10 girls donned red outfits at a dance recital. Donned just means that's what they wore, that's what they put on. What fraction of girls wore red outfits? Well, we're doing a fraction, and we said it's always easiest to start with the whole, and it tells me, well, it doesn't tell me, does it? Doesn't tell me how many whole girls went to the, so what do? Well, let's see. I know that 20 wore green, and I know that 10 wore red. So if I know that 20 wore green and 10 wore red, then if I put them together, then now I know there was 30 girls. Okay, so 30 girls went to the dance recital. And then my problem asked me, what fraction of the girls wore red outfits? Well, we said that 10, so that's the part of the girls that wore red, is 10 was red. Now, let's see, is there any number? So I know 10 30ths wore red. Oh, and remember what we talked about earlier? Yesterday, we were simplifying fractions. We talked about if they end in 0, we know that they're divisible by 10. Okay? So 10 divided by 10. When we're working with tens, we can just do quick mental math on that. So 10 divided by 10 is 1, and 30 divided by 10 is 3. And we said that anytime you reach a 1, we know it's in simplest form. So we don't even have to think to go simplify that one anymore. So 1/3 of the girls wore red. Okay, and number 5. A section of Tina's bookshelf had 15 French books and 6 Spanish books. What fraction of books on the shelf are in Spanish? Well, we're doing a fraction. It's easiest to find the whole first, so we need the whole number of books. Didn't give me that, did it? Didn't give me how many books she had altogether, but it did tell me that she had 15 that were in French, and she had 6 that were in Spanish. Okay, so if I know she had 15 French ones and 6 Spanish ones, if I put those together, then I'll know how many books were on the shelves altogether. So 5 plus 6 is 11, and we carry our 1. 1 plus 1 is 2. So she had 21 books on the shelf altogether. So now I know she had 21 whole books on the shelf, and the question asked me what fraction of the books on the shelf are in Spanish. Well, if I look where I wrote my information down, I know that 6 were in Spanish. All right, so I know that 6 out of the 21, or 6/21 of the books are Spanish. And then I have to see, is there anything I can divide 6 and 21 by and get 0 remainder? Okay, 2, I can divide 6 by 2, but I can't divide 21 by 2 or I'd get a remainder. And let's see, 3, I know 6 is divisible by 3. And oh yeah, from my math facts, I know that 21's divisible by 3. so if I divide each one of them by 3, 6 divided by 3 is 2. 21 divided by 3 is 7. All right, so I've simplified once, and let's see. Doesn't have a 1 in it, but remember that doesn't always mean it's not already in simplest form. Is there any number? No, because 2 doesn't work, and I can't go above 2, can I? So I know that 2/7 of the books were in Spanish. All right, I'm gonna leave you guys to do page 3 on your own and turn in to me, and I'll see you guys later. Bye-bye.